All right. Just to do a little bit of bookkeeping. Yesterday I spent a lot of the video complaining about the Chinese remainder theorem and how I did not think that was a great question just because who knows the Chinese remainder theorem? Um, and so someone on YouTube left a comment and suggested essentially the same approach, but a simple approach to it, which is as follows. I went and implemented this afternoon. I have some divisors, I have some remainders, and I want to find the smallest number such that for each of the divisors, um, that's the remainder. I want to find one number such that, when I divide by 37, the remainder is 0. When I divide by 41, the remainder is 14, and so on. And one way to do that is to say, you know what, I'm going to start with the first remainder and have this notion of an increment, which is the first divisor. And so the invariant is that my solution at any stage is going to satisfy this divisor remainder condition for like the first n numbers. So here, if I take this solution and I divide it, mod it by the divisor, obviously I'm going to get the remainder because that's all that there is. And then this, what I call the increment, will be the divisor. And so at every step, I want it to be the case that the solution mod each of the first I divisors equals each of the first I remainders, but also that what I have, basically the increment is divisible by each of those first divisors. And what that means is that I can add multiples of that increment to my solution without changing that first condition. And then what I do is I just walk over this list and I say for each of the remaining divisors and remainders. And so I have this increment that I keep adding up until I get to the right modulus for that next one. And then I multiply with that and I keep going. And it turns out to take not very many steps. So what I mean is this. I start off with the solution being 37. Or no, sorry, the solution being 0 and the increment being 37. And now I want to find so I know that 0 mod 37 is 0. And now I want to find, something that meets that, but also when I mod by 41, I get 14. So I just started adding 37 to that. And, after a number of tries, I'll get one. And then I start adding 37 times 41 to that. And because I'm adding 37 times 41, I'm not changing either of these first two conditions. And I just walk down the list, and it turns out that this works out pretty well. So that was nice, and I wish I had come up with that, but I didn't. So, maybe next time. And let us see what the problem is for today, because I think it's about to start. Day 14. So your ferry approaches the seaport. The captain asks for your help again. The computer system that runs the support isn't compatible with the docking program, and the ferry says the docking parameters aren't being correctly initialized. To brief instructions, you have the seaport to make sure this uses a strange bitmask system initially. With the correct order chip, the initialization can either update the bitmask or write a value to memory. Values of memory addresses are both 36-bit unsigned integers. For example, ignoring bitmasks for a moment, a line like mem8 equals 11 would write the value 1811 to memory address 8. The bit mask is always given as a string of 36 bits, written with the most significant bit, representing 2 to 35 on the left, and the least significant bit on the right. The current bit mask is applied to values immediately before they are written to memory. 0 or 1 overwrites the corresponding bit in the value, while an X leaves a bit in the value unchanged. For example, consider the following program. Mask equals this. This program starts by specifying a mask. The mask will overwrite 2 bits in every written value. The 2's bit is overwritten with 0, and the 64's bit is overwritten with 1. The program then attempts to write the value 11 to memory address 8 by expanding out. Let's apply this values. Value equals this, mask equals that, result equals that. So because of the mask, the value 73, certain memory address 8 instead. The program tries to write 101 to address 7. So the mask has no effect as the bits are already set. Finally, it tries to write 0, 64 to initially. For example, you need the sum of all values left in memory after the initialization program completes. The entire 36-bit straight initialize the value 0 at every address. In the above example, only 2 values in memory are not 0. So we execute the initial program. What is the sum of all values left in memory after it completes? Okay, so this seems slightly convoluted, but and the mask can change. Okay, so that's good to know. And let's get the sample program as well. And just do this. Raw equals this, and let's say program equals raw dot split on new lines, and import RE, and let's do mask regex equals mask equals this, and let's do mem regex equals r mem 0 to 9 plus equals and are those interpreted as binary numbers or as decimal numbers? Value 11 decimal numbers. Okay, so 0 to 9 plus no equals 0 to 9 plus. Okay. And good. Def run program, which is a list of strings, and it is going to return, let's say, a dict. So from typing import dict and list, and it is going to return a dict from int to int, and from collections import default dicts. So let's say memory equals default dicts int, and at the end of the day I'm going to return memory. Okay, so that's that, and now let's think about how to do this. For line in program, if line starts with mask, and maybe I won't even use this regex, mask equals line dot split on the equals sign -1, and let's say mask equals none. Otherwise, it's one of these mem things. And so let me just, I can't remember how to do regexes off the top of my head. Let's see, I don't need the mask regex, but let me do this. And let's say line equals this, re dot match mem regex line, unbalanced parentheses at position 11. was this m.group? No. Why am I not capturing? Alright, well, screw it. I won't use a regex then. Let's say mem comma value equals line dot split that again, and let's say value s value equals int value, and if I split on this equals and take the 0, and pause equals int of mem, and I want to start 4 to minus 1. Yeah. 4 to minus 1. Okay. And now what I want to do is I want to say value equals apply mask, value comma mask, and memory pause equals value. I think that was what they said they wanted us to do. So 2's bit is over in 64's bit, and then try the value 11 to memory dash 8 by expanding everything out the mask. Okay. And so now we just need to write, and this is only 500 instructions, so I can just do it the really slow way. Apply mask. Value int mask, which is a list of strings, and it's going to return an int. And so what I want to do is I want to say for I am in enumerate reversed mask. Okay. And what I want to do is I want to say if m equals 1, elif m equals 0, else do nothing. So if m equals 1, I want to set that bit to false. So I want to say value equals value and let's say 2 to the I. Otherwise, if m is 0, value equals value XOR 2 to the I. So this is, again, me being tricky with bit arithmetic, but I think that's going to work. And then return value. And mask is actually a string, so that's fine. So run advent 2020 day 14.py, and now let's say run program. What did I call it? Just called it run program, and it says 8 is 0 and 7 is 64. So okay, so I got close, but I did not get it right. So let me Print applying pos value, print set mask to mask, and print after mask value is value. Okay, so let's do it that way and see what happens. Oh, I need to rerun this. Set mask to this, applying 811 after mask's value is 0. Oh, I know what I did wrong. This should not be an and. This should. If m equals 1, I definitely want to turn it on, and if I definitely want to turn it off. So let's try it that way, and I'll talk a little bit about that. 866, 7103. So that still seems wrong, but it seems wrong in a different way. Okay, so 11 after mask value is 73. That seems right. Then it tries to write 101. This time the mask has no effect because, and then applying 8064 is written instead. So there's something I'm doing wrong. And what am I doing wrong? Print m I 2 times I. Let's try this again. So 0, 1, so this is 2, so I turn off 2, and this is 1, 2, 3, 4, 5, 6, which is 64. And so when the program tries to write 101, 101 and 64, and 101 and 1, which is 1. So those both are bit set. So let's figure that out. So that's 2. 101 and 2, which is 0. Okay, so mask is 0, and I want 101 x or 2. You know what? Maybe this one should be and. No, I don't think that's right. So m equals 0. I want to turn that off. So that means that well, here, let's do this a real stupid way. If value and if not value and 2 to the I, value plus equals 2 to the I. So rather than being stupid with bit arithmetic, I'll do that. If it's 0, then I say if value and 2 to the I, value minus equals 2 to the I. Okay, so I think that will work. And let me try it again now. 864, 7, 101. And I think that was what they wanted, right? And so it returns 165. And so let's say memory equals run program, and assert that sum of memory.values equals 165. So now I'll say program equals line for line in F. Memory equals run program and print memory dot values. No, I want to print the sum of memory dot values. Alright, so now let's run this again. And I have too many prints, but anyway, let's copy that and see if it works. That's not the right answer. Right, well, let's look at my just this, and raw2 is that, and we can play around with that. Lines equals raw2 dot split on new lines. Okay. Mem equals run lines. Alright, well, let me try writing this the stupidest possible way, which is as follows. Output equals 0 for I am in enumerate reversed mask. Or if m equals 1, output plus equals 2 to the I. If m equals 0, pass, else it's an x, so output plus equals 2 to the I and value. Okay, so let us see if that works with my unit test, and then with that's the same thing I guessed. So let me read the instructions, see if there's anything I missed. C40 is a strange bit mask system. You don't can either update the bit mask or write a value to memory. Values are just put 36-bit assigned integers. For example, ignoring 8-bit mask for a moment. A line like mem8 equals 11, write the value 11 memory address 8-bit mask is always given a string of 36-bit. Most significant bit on the left, least significant bit on the right. Current bit mask is applied to values immediately before they are written in memory. 01 overwrites corresponding to the value. X leaves the bit in the value unchanged. For example, let's say the following program. Specifying the mask. Program then attempts to write the value 11 to memory address 8 by expanding everything out to individual bits. Sum of all values left in memory. The type begins to select value. For example, only 2 values in memory, not 0. What is the sum of all values left in memory after it completes? Am I parsing the input wrong somehow? That's not the right answer. If you're stuck, make sure you're using the full input data. 161753. What's the full input data? All right, let's figure out how to debug this. Let me do this for a second. Set mask to that, after mask, okay, so this mask looks like it should set those to approximately that. So, I'm sort of at a loss for what I'm doing wrong here. 3267. Okay, so I don't apply this mask to 3, 2, 6, 7. 0, so I get 0, 0, so I get 0, 1, so I get 4, x. Let me do. Do that, that'll be easy enough. Okay, so 3, 2, 6, 7 has a 1, it has a 2, it 1, so that gives me 4, it has an x and a 0, so that stays 4. Now it has a 1, so I get in the 16, it has an x and I'm not there, so I don't add anything. It has a 0. Alright, let me 36, and it's going to give me a list of ints. And let's see, digits equals this, for blank and range num digits. Digits dot append value mod 2, value equals value divided by 2, and return list of reversed digits. Okay, so what was it, 3, 2, 6, 7? It's going to give me a bunch of stuff. So let us do apply mask 2, and let's say digits equals 2 binary value, and output equals 0, and now let's say for digit m in zip digits mask, if m equals 1, so I equals 1, elif m equals 0. Okay, and now what I want to do is I want to say return sum of digit times 2 to the I for I digit in enumerate reversed digits. So now let's run this, and we have apply mask that, and then apply mask 2, which gives me the same answer. Let's try apply mask 2 here and run it again. 429. So I think, is that the same one I had? No, it's not. Why did I get a different answer? That is the right answer. Okay, I don't know what I did wrong. Version 2 doesn't involve it changes the memory address encoder. Memory for values of memory. Each bit modifies the corresponding bit. By the way, the bit mask bit is 0. The corresponding memory address bit isn't changed. The emphasis is 1. The floating bit is not connected to anything, instead fluctuates unpredictably. In practice, this means floating bits will take on all possible values, potentially causing many memory addresses to be written all at once. For example, considering the following program, the program gets memory address 42. It first applies the bit mask. After applying the mask, 4 bits are overwritten, 3 of which are different. I'm just going to delete apply mask 1 since it didn't work. And I don't know why it didn't work. Actually, no, let me... do not use doesn't work. Alright, I don't know why it didn't work, but to apply the mask, 4 bits are written, 3 of which are different, and 2 of which are floating. Floating bits take on every possible combination of values. With 2 floating bits, 4 actual memory addresses are written. Next, the program is about to write to memory address 26 with a different bit mask. This results in an address with 3 floating bits, causing writes to 8 memory addresses. The entire 36-bit address space still begins to initialize the value. You still need the sum of all values left in memory at the end of the program. This example, the sum is 208. Execute the initialization using MLI version 2, but some of it. Okay. Good. Def run v2, run 2 of program, which is a list of strings, and it's going to return an int. And again, no, it's not going to return an int. It's going to return some memory. It's going to return a dict from int to int. Memory equals default dict int. Let's just copy this. Okay, so that's easy. That's good. And that's the same. And now for all possible values, for pos2 in multi-pos, pos mask, memory pos2 equals value. Okay, and so now I need to write this multi-pos. Def multi-pos, which starts with a pos as an int and a mask, which is a string, and is going to return an iterator of ints. So iterator, I guess I'm not using regular expressions. Okay. And so what I want to do is the following. Basically, when I see a 0, I get a 0. When I see an x, so now I want to generate, so let's say x's equals I for IC in enumerate mask if I'm going to cheat a little bit. Mask equals list mask. Okay, x's equals IC for IC and enumerate mask if C equals X. So I want to find the positions where there's an X. And now what I want to do is I want to use itertools combinations. No, I want to use itertools product. Okay, and So for subs in import iter tools, iter tools dot product of and let's say sub values equals 0, 1 for blank in x's. Okay. And now let's say for choice in iter tools dot product let me for iter tools. So iter tools dot product of 0, 1, 0, 1. Let's see if this works or if I need a star around it. I need a star around it. Okay. Sub values for index C and zip x's choice mask index equals C. Yield apply mask 2 for pos and mask. Yeah, that's fine. I think if I change this to iterable of strings, that should work. No, it won't work. Well, whatever. I'm going to apply mask 2. I'm not going to worry about it. Multipos. So let's say run 2 of program and see what happens. Doesn't like that. Eight, 11. Okay, so now let's okay, so that never gets anywhere. There's not that many X's in there, are there? Oh yeah, there's a lot of X's. Oh god, that would be the problem. Maybe I should not have used that one. Program 2 equals raw2 dot split on new lines. Memory 2 equals run program 2. Seriously. Search sum of memory 2 dot values equals 208. Yeah, that's still not right. All right. Let's see what I did wrong here. Set mask to this. I can take out those print statements. I don't think I need them. And they're just going to confuse me. Oh, actually, those weren't part of my thing. Well, anyway, let me take them out anyway. Okay, mask equals this, mem42. I split it out, and it says in positions 30 and 35, I have X's. And now let me okay, so 1011 1011, and then also this X in the 6th position. Okay, so that gets me all the correct things. And let me print value, yield value. Okay, so that says that 18, 19, 50, and 51 all get set to 100. Why is that? 2, 4, 6, no, 2, 4, 8, 16. So that looks like 18. So why is that? $42. 18. Okay, why am I 2 digits 42? 2 binary 42. Seriously. One, two. X1001X. After applying the mask, 4 bits are overwritten, which 3 of which are different and 2 of which are floating. Floating bits take on every possible. Okay, mask is this. So there's something that I'm missing, like deeply fundamentally, which is as follows. The address is 42, which looks like this. Mask is 0. So how do you get a 1 here? Because 0 is unchanged, and the bit is overwritten with 1. That's the problem. Alright, I read the problem wrong. here's what I need to do. Apply multi-mask, and this is going to be an iterator of int. So some of this logic is going to need to come up here now, which is x is equals I c for c. Okay, print mask equals, actually no, so I don't need to do it like this. Okay, that we can do. And now, if m equals 0, okay, then output output plus equals let's do this just so I can copy what I did before. If m equals 0, then pass, leave the digit as is. Otherwise, if m equals 1, new digits I equals 1. Otherwise, new digits I equals next of it. And then what we want to do is we want to yield this thing. Okay, so apply multi-mask. Apply multi-mask, pause, mask. Alright. Unexpected indent. Do I even need this? Insertion error. Okay, so that didn't work either. Okay, so my choices look pretty good. New digits that should have been. Okay, so that actually worked. Let's see if this one works. That is the right answer. All right, I can't say I enjoyed that. What a pain in the ass. So, to recap, my first attempt at applying the mask didn't work. I don't know why. My second attempt involved converting it to binary and applying the mask and doing it. And then for the second one, I needed to, wherever there was an X, sub in every possibility. I used two tricks here. One was I used itertools product. So I basically said, here's the places where I need to substitute something in. I want to try subbing in both 0 and 1, and I'll need to do it that many times. So I made a list of values to substitute, and now I use itertools product, which gives me every possible, product of those. And then the one thing I did that was sort of clever was that I know that, let's say that choice is like a 3 tuple. That means I'm going to have 3 values to fit in. So what I'll do is I'll just get an iterator, and then whenever I see an X, I'll grab the next thing off the iterator and substitute it in. And so this, yeah. So this was a real mess. Part of it was me not reading the problem carefully enough, and part of it was, I don't know what it is. Anyway, yeah. Awesome. Only took an hour. See you tomorrow.